Welcome to episode number 9, How to Fly to Mercury. Today I want to explain the Mercury orbit insertion. When we come from outer space, from interplanetary space, we are too fast. If we do not brake at the close point to Mercury, we would fly by and not get into an orbit. With normal satellites, you have big orbit insertion engines. ExoMars had an engine of 400 Newton, but Baby Colombo has little tiny cute 20 Newton thrusters. So rather than making one big burn, we will make 15 burns. And we have a lot of constraints, so it's a huge optimization problem. Vanessa, can you come here and help me to explain it? So we are flying here with our spacecraft and try to do our orbit insertion burns. We want to get MMO at an altitude of 12,000 kilometer altitude. I have to explain this here is the peri-Herm. Herm is for Hermes, it's Mercury. This is 400 kilometer, and for MMO we want to get to 12,000 kilometer upper Herm. The MPO, we want to get to an orbit 400 kilometer by 1,500 kilometer. So we have now approaching here, and now we want to do our insertion burns with the thrusters forward, where the velocity in the velocity direction. So here we have to brake the velocity. And when we come here, we would get the sun would shine on our thrusters. And they might get too hot, can even explode. So at this point in the orbit, we cannot thrust. Only when we reach this point, the sun is no longer hitting our thrusters. When we continue here, our thrust burn, we would get sun on the MMO. And this poor little guy, he's afraid of the sun. That's why he flies to Mercury. He has a sun shield to protect him. But we have a little area here where we can thrust. So the attitude is very constrained. Also, you cannot thrust when the when Mercury is close to the sun, because then everything is too hot, and again, we don't want to thrust there. We have another problem when we want to command our spacecraft. When it's too close to the sun, we have to send the signals, they pass close to the sun, and they get distorted due to the solar corona, and the signals might not arrive in the proper state. And this is called superior conjunction. So we have this area also to avoid. We want to change the orbital line of apsides. Have I forgotten the constraint? Of course, yeah, our flight dynamics people, they want to have 3 days between the maneuvers in order to have enough time to check the previous maneuvers. So it was a optimization problem to minimize the fuel, but with a lot of constraints. Luckily, I have 2 very smart colleagues, Daniel Garcia and Anja Schuster. They helped me to solve this problem. And now, if everything goes right, 5th of December 2025, we have the first orbit insertion maneuver. And on the 14th of March 2026, hopefully the success of the 14th insertion burn. Let's cross the fingers that everything goes right. And then we have a perfect Mercury orbit insertion.